Hi guys, Harry here. Welcome to Scrap Science. Around 4 months ago, I finished off a very long-running series on this channel in which I tried to extract heavy water out of regular water. What I tried to do was electrolyze a really large amount of water down to a really small volume, and in theory what that should do is leave behind or enrich a lot of the deuterium content of the water. So after you electrolyze something like 20 litres of water down to a single milliliter, what you're left with is quite a high concentration of heavy water or deuterium oxide in water. Now if you watched that series, you'll know that it didn't work. The tiny amount of water that we ended up with at the end, which I still actually have, see that tiny little bit of water in there, it wasn't measurably concentrated in deuterium at all, in that it wasn't any heavier than normal water and it didn't have a separate freezing point. Anyway, it's been 4 months and I think I'd like to give the extraction another go. So in these 4 months I've been looking into ways of making it work. I've been reading every single paper I can find online about this electrolytic separation of deuterium from water, and I think I found the thing that I did wrong last time that I'll be doing this time to make sure it actually works, and that is using an ion electrode as the cathode, because the cathode with our electrolysis is the electrode that generates our hydrogen, and that's the electrode that will be doing the separation between the hydrogen and the deuterium. Anyway, apparently metallic iron, or steel even, has a really good separation between those two isotopes of hydrogen. So that's what we're going to be using. I've got these steel pipes which I've cut up. These will be what we're using as our cathodes. I'll need to degalvanize them first, but they should be very good, nice high surface area. They should work well. What we're using as our anodes are these strips of nickel, which, as we saw when we built a hydrogen generator, when we use these in a sodium hydroxide electrolyte, these don't corrode, so hopefully the cells will last right until we electrolyze through our large quantities of water. Anyway, I'll put together one of these cells just loosely and show you what the setup's going to be like. This is what I'm thinking basically. We've got our steel pipe, I've got some PVC fittings on the end just to contain it, and then I've got down through the pipe those nickel strips which will be acting as our anodes. Anyway, these will be siliconed in properly, and what we'll do with this is we'll put this in one of these Tupperware containers and submerge it in a solution of sodium hydroxide, and the electrolysis will go on inside the pipe. And then I've also put a hole up the top there where we can put a tube, and the hydrogen and oxygen gas that we generate depleted in deuterium we can take out and scrub for any sodium hydroxide electrolyte vapors that come out of the cell. You can see I've also put a hole down the bottom here just so that the water can actually flow into the cell from the surrounding water, but I'm pretty sure that this should work pretty well. Our electrodes are inert and should last a pretty long time. What I'm hoping is that each one of these cells will run at 3 volts and 10 amps. It'd be really nice because then we could put all 4 cells in series. So if we have all these, get these containers apart, we have all of these cells running next to each other, each of them in series, we can run the whole device on like a 12 volt 10 amp power supply, which I have in the form of some PC power supplies. This is actually a big improvement from last time we did the extraction, because we'll be able to process 4 times as much water in the same amount of time, because we were running the cell before. Last time we did the extraction at 10 amps, and this time if we run 4 cells at 10 amps we'll be running 4 times quicker. And also the cells are much bigger. They're like 10 times as big as our cells before. So whereas previously we had to refill the cell every 48 hours, with these cells, we'll only have to refill every month or so. So hopefully once we put these together properly, it will work nicely. Anyway, our first job is to degalvanize these pipes. It shouldn't be strictly necessary because the zinc that coats the steel pipes isn't actually a complete coating, because it's just galvanic protection. And when we do our electrolysis in these cells, the iron cathode actually has a much lower over potential for hydrogen generation than zinc does. So the iron metal surface should generate the hydrogen much preferentially to the zinc surface, but just to be safe, I'm going to dissolve the zinc off with a solution of sodium bisulfate. Do that now. After about half an hour, the reaction has nearly come to a stop. The solution has slightly changed colour, and pretty much all of the zinc has come off the pipes. So there's just a tiny little bit left there, you can see, but pretty much everything else is removed. And now it's just the iron slowly reacting with the sodium bisulfate. Hopefully all the internal bits of the pipes have been cleaned of any zinc. Looks like it. I mean, there's not really many bubbles coming out of the middle of those pipes, so that's good. I'll leave this for another 10 minutes or so just to make sure we get rid of all of the zinc. Righty, 3 out of 4. These are done now. See, they've only got tiny little specks of zinc left on the surface, and as far as I can tell, there's none on the inside, so that's good. Still one that we just got to get rid of a little bit more zinc, but that'll go ahead while we do the next step for these 3 pieces. That next step is to put on this threaded PVC joint, just so we can make a proper connection to the tops of the cells, so that we need the top of the cell to be somewhat airtight, so that we can collect the gas coming off the cells, because they'll be in there like this, and the top of the cell is obviously where the gas is going to come out. So what I think I'll do is just put a tiny little bit of silicon sealant just on the thread there, and then screw on the PVC fitting, and hopefully that will create a nice airtight seal. And there we go. I've tightened up these caps really tightly, so I don't think they're coming off later on, which is fine because they'll be like this forever. You can kind of see down here that the iron has already started to rust without that galvanic protection, but that's alright, because as soon as we put them into the cells and start running current through them, they'll be cathodically protected and they'll get rid of that rust very quickly. Anyway, I'll let the silicon dry, and then we'll come back and put these caps on along with the anodes, which we'll put down through the pipes. Yep, those lids never coming off again. Next step is the anodes, which we'll just slide through the slits that I've made in these lids, and then push them right through the pipe. And the anodes now in. I'll just go ahead and put these caps on the bottoms of the cells, and then hopefully we'll be able to just silicon it all up. I know I've skipped over quite a bit of the construction, but these are pretty much done now. I've sealed up the tops, so hopefully no gas escapes out there. It'll all just go through these tubes. And I've also somewhat sealed up the bottom just to hold the electrodes in place. But we've got the hole there just so that the electrolyte can actually get into the cell. And basically what these are going to do is, with these 4 Tupperware containers, they're going to be positioned something like that. Put something in to hold them in place, but that'll be sitting there. All of these tubes will go into some central gas scrubber filled with maybe like some dilute sulfuric acid or something to catch the sodium hydroxide vapors that are coming out of each one of these cells. And then hopefully we'll be able to get that 10 amps of current through these 4 cells. And whoosh, the system is pretty much complete. Got a bit sick of filming every single step that I did, but it's pretty much done now. We've got the 4 cells all complete. I've got the central bubbler, and this big container just to contain everything. Maybe I'll put some coolant water in this just to make sure that none of these cells overheat. Anyway, I've soldered everything together and put on some of these little connectors to connect everything up. So for starters, we've got 12 volts coming in here, goes to the anode of our first cell, then the cathode of that cell goes to the anode of the next cell, the cathode of that cell goes to the anode of this one, and then the final cathode goes to the anode of this one, and then the cathode of this one will be 0 volts. So we're going to connect everything up in series, 12 volts through to 0 volts, and hopefully that should work nicely. But yes, technically now all we have to do is fill up each one of these with some sodium hydroxide, maybe put a bit of a weak acid into the central bubbler, then all the sodium hydroxide mist that comes through with the oxygen and hydrogen will get scrubbed out pretty well, I think, as I said before. And then we'll hook up 12 volts to the power, and maybe put this current meter in series, and we should be good to go. However, I think I might just do a test of one of the cells at a time just to make sure that they're going to work. So I'll set that up and we'll test maybe this cell at 5 volts rather than the 3 volts that each one of these will be running, just to double check that we can achieve a high current with the cells that we've got. Anyway, yes, I've got some water in one of the cells ready to go. Got the bubbler ready, and one of these cells, I've got the amp meter hooked up to the power supply. And what we're going to do is just add a little bit of sodium hydroxide into this to make it a good electrolyte for electrolysis, and then we will put our cell in and slowly add some more sodium hydroxide until we get a reasonable current at 5 volts. Just going to start out with a relatively small amount of sodium hydroxide, just enough to make it conduct electricity. As far as I'm aware, Tupperware containers, polypropylene, I think, should hold up to the concentrated sodium hydroxide, at least according to its chemical compatibility chart. So hopefully the container doesn't just dissolve, that'd be bad. Alrighty, everything's hooked up. I'll go ahead and stick the cell into the sodium hydroxide. Everything seems good. Put the bubbler tube into the bubbler so we can see the gas outlet there, and then if we turn the power supply on, we should see a little bit of current. Whoa, that's quite a bit. Very exciting. So this is looking like it's going to be way easier than I thought. I thought I was going to have to add like bucket loads of sodium hydroxide to the cell just to make it like conduct a little bit of current, because there's nearly 2 litres of water in this cell. But looking at the current now, that's like 5.5, 6 amps, and you can see all that gas coming straight out there. You can even see some hydrogen forming on the outside of the cell, because we do have exposed, the anode's exposed on the outside a little bit, so a little bit of current will flow that way, but for the most part the gas is flowing out here, which is very, very good. And okie dokie, I've filled up the rest of these cells with about the same concentration of sodium hydroxide as our first one, and I've hooked it up to 5 volts just to start off with, just in case I've miscalculated something. Connecting it up to 12 volts might not be a good idea, but when we turn this on we should see a little bit of current start flowing. Because of the low voltage, it shouldn't really be all that much, but we should see some hydrogen and oxygen gas forming and bubbling through our central bubbler. So as soon as we turn this on, we might see some current. Not much, no. But that does make sense, because each cell is only really getting round about 1.6, 1.7 volts, which really isn't enough to kickstart electrolysis to a reasonable degree. So 5 volts, not much happened, but now connecting it up to 12 volts results in about an amp of current flowing, which is pretty good because across 4 cells 1 amp flowing is about the same as having 1 cell with 4 amps flowing. So it's pretty good, and as the cells warm up due to the power going through them, that current will also increase because the resistance of the cells themselves will decrease, and hopefully if we leave it for long enough, maybe that current will build up. I'll almost definitely have to add quite a bit more sodium hydroxide in order to increase that current, because we do want 10 amps eventually, but I know how quickly the current can kind of creep up on you as the cells heat up, so we don't want to just go straight for 10 amps straight away. We want to work our way up slowly. Anyway, we should be able to see, hopefully, some hydrogen and oxygen gas coming out of those tubes. Yeah, there we go. Excellent. So we are actually electrolysing our water, and hopefully once we build it up to 10 amps, in a month or so, all of this water will be reduced down to a much smaller volume, and we will have enriched the heavy water content. I guess I'll leave this going and we'll be all set for deuterium production over the next ages, I guess. What's really cool about running it at 2 amps, maybe nearly 2.5 now, is the fact that the current that we're running at now generates about the same amount of hydrogen and oxygen gas as we would have been generating the last time I tried this. So in the last series of heavy water production, I was running the cell, I only had 1 cell, and I was running it at 10 amps. And now that we're running about 2.5 amps through 4 cells, we're pretty much doing the exact same thing. Once we build that up to 10 amps, we'll be running 4 times quicker than we were before. After another 15 minutes, current has increased dramatically. We've got 5 amps now. A little bit worried that it might go above the 10 amps that we want, but we'll see. We are now generating a whole bunch of hydrogen and oxygen gas from each of our cells. So this now means for each cell, 3 volts, 5 amps. We're putting 15 watts of power into it, about 9 or 10 watts of which are going towards heating the cell, because about a third of the energy that we're putting in to the cells is actually going into generating the hydrogen and oxygen gas from the water, but the other 2/3 of the power is going straight into heating the cells. So we've got about 10 watts of heating for each of these cells, which hopefully won't heat them up too much, but if it starts to get too hot, the current starts to rise too high, I'll add some coolant water just around. That's what this big tub is for. So I'll leave it for a few hours, and hopefully we won't have to do that. It's now a couple of hours since we started. The current's pretty much tapered off at around 6 amps. It was up to 6.5 amps before, but it's cooled off through the day. The actual cells themselves are not really very warm at all, maybe a little bit, but I wouldn't expect them to heat up all that much because there's not all that much power going into each individual cell, only about 18 watts per cell now. Just as before, we are generating a whole bunch of hydrogen and oxygen gas. This cell has a small leak. I don't know if you can see just on the side there, you can see where it's just bubbling out the side of the silicon. I'm going to have to re-silicon that up pretty soon to make sure all the hydrogen and oxygen is actually going into this cell. And then, as you might be able to see, as the bubbles come up from the outside of the cell, we actually get a fair bit of sodium hydroxide like mist hitting the lid of the container. I'm just a little bit worried that a bit is escaping through the hole. So what I'm going to do is maybe just get some duct tape and try to cover that hole as best we can. Don't want to completely seal it because there's still going to be a build-up of a little bit of hydrogen and oxygen gas inside this container, which isn't very good. Maybe I'll drill some holes in like the other end of the container. I don't know. But I'll get that done now. And that's good to go. I think I've covered pretty much all of the spaces where the sodium hydroxide mist can kind of escape, and I've left enough room in there for all the hydrogen and oxygen to escape, and these lids aren't even on properly, so I think that should be fine. We are generating a whole bunch of hydrogen and oxygen through our bubbler. I did seal up that cell there to make sure that none of the gas just escapes into the atmosphere straight from the inside of the cell. The current seems to be kind of jumping around a bit. We've got a little bit more than 5 amps flowing, which should destroy, with these 4 cells together, about 100 millilitres of water every day, which is pretty cool. Once we reach 10 amps, then we should be able to destroy about 200 millilitres a day. But with that, I think I'll leave it going overnight and check on it in the morning, and maybe increase the concentration of our electrolyte to bring the current up. Next morning, the cells have fared pretty well. I mean, we get quite a bit of evaporation happening within our cells, but you know, that's alright because it's all contained. I don't think there's too much vapour escaping, and even if there is, we're in the really early stages now. It doesn't really matter if we lose water that's not concentrated in deuterium anyway. One thing that I've noticed that's happened overnight is the fact, however, that the current has really tapered off. We only have maybe a little bit more than 1 amp now after leaving it running for 12 hours or so, a bit more, whereas we were getting 6 amps, nearly 7 before, which, I don't know, it's a little bit weird. I guess maybe the temperature does just change the current that much, or maybe we get like an initial high current when we do this and then it kind of tapers off and settles around 1 amp. Either way, I'm going to add some more electrolyte into our cells, and hopefully that'll bring the current up a little bit more. Anyway, I'll go ahead and try to, over the next few days, add electrolyte just to make the current stable at, I don't know, something around about 10 amps hopefully. And then in a month or so, hopefully I'll make an update video, and the volume of our 7.5 litres, maybe 7.5 litres of water will be significantly reduced and enriched in heavy water. But I think that'll be just about it for this episode. There's nothing else I can really show you. Hopefully I'll give you an update soon, and hopefully this whole process actually works in generating a small quantity of heavy water eventually. But till then, see you later.